In this video, I'm going to show you how simple it is to integrate your existing ESP8266 Arduino Core project with Deploy the Fleet. And so to get started, the first thing that you want to make sure you've done is select the proper board from the board menu here. As you can see, mine is the Adafruit Feather Huzzah ESP8266. And that means that you've got the board manager installed correctly, and you'll also, of course, need the ESP Arduino Core library installed as well. And so just to show you what we have here to get started, just as a base code example, you see I have the Feather Huzzah with a LED blinking at a half-second interval there. And I've prepared a code sample here, but imagine this is your code. Whatever your project or product firmware looks like, this is just an example starting point of how you would integrate with Deploy the Fleet. And so looking at the code there, it's very simple. Just as an example, we have a version number, which will come in handy here in a minute. And then in our setup, all we're really doing is, as you can see over here on the serial monitor, is we're outputting sort of this 321 and then the version. The point of the 321, it actually starts at 4, is to give you a minute after you, not a minute, a few seconds after you plug it in to open up the serial monitor and still catch the output before it gets into the main code. And so that's all we're doing in setup. Additionally, we're connecting to the Wi-Fi. Just for example purposes, I'm using the Wi-Fi credentials as pound defines, which I've stored over here in credentials.h just to hide them from view, but you can put them directly in there, or even better yet, have some sort of Wi-Fi manager to do that for you. And then in our loop, all we're doing is waiting to be connected to the Wi-Fi, and then we're flashing the onboard LED like I showed every half second. And so imagine this again as your firmware. It would look very different, but integrating with Deploy the Fleet, the concepts are the same. We've tried to make this as simple as possible. And the first thing that we need to do is to get the library. We've created a library for the AD266 as well as the ESP32. And the way you would add that is just come up to Sketch, include library, manage libraries. And then from here, you'll just want to filter your search by DTF, Deploy the Fleet. And when you do that, you'll see we have two libraries, the ESP32 update and the 8266 update. And I have them both installed, but you would just select the latest version. As of this video, that's 1.0.1, and click install, and you'll be good to go. Once you've installed the library, you have to include it in your project. You just do that by saying DTF underscore ESP 8266 update.h. And contextually for your firmware, you'll want to add this code wherever it makes sense. It might be pressing a button to trigger an update, or some web UI that you've created over SoftAP to trigger an update or a reset. In our case, just to keep it simple, when the device boots up in the main loop, a single time we're going to check for updates. And the way we'll implement that is just by saying static bool checked for updates equals false. And then down in the loop here, because we need to make sure that we're connected to Wi-Fi, we'll say if not checked for updates, then run this code. So we'll say checked for updates equals true, because we only want to do this once. And then checking for updates with Deploy the Fleet is a single line of code with the Arduino Core library. It's just DTF underscore ESP 8266 update get firmware update. And this function takes two parameters. One is your custom update URL that we'll get out of the Deploy the Fleet dashboard here in a second. And the second is the version number, which helps with the decisioning in Deploy the Fleet of what firmware update to give you. And so we'll just put that there, and we'll fill it in a second. And over here, we'll use our current version variable. And it needs to be a C string, so we have this handy C underscore stir built into the Arduino language that will help us. And so to get this, we just come over to the dashboard. You can see I've created a product, ESP8266 example. There are no firmwares or devices, as you can see by the dashboard being empty. And all we need is this update URL. If you click on the handy copy button over here, it'll say update URL copied. And we'll come back over and we'll just paste that in. Hit hit verify to make sure we didn't make any mistakes, and that's it. That's all it takes. Again, it's that single line of code. I added a little bit of helper code around it to make sure it only happens once, but again, based on your project, you might do this with a button click or some other interaction with your device to trigger this update. So that built just fine, which is great. And now what we need to do is make Deploy the Fleet aware of this version of our firmware. And to do that, we can just come up to Sketch and say Export Compiled Binary. And what that will do is that will build your sketch and then export it to the same folder that you've stored your sketch in. So depending on your operating system, wherever Arduino creates these new sketches that you create, this is where it will export the binary. And so I'm going to come into Deploy the Fleet, come to the Firmware tab. You can see I have no firmwares here. I'm going to say Upload a new firmware. And then you can either click here to open a file picker dialog, or you can just drag it over. So I'm going to drag it over from the folder where Arduino exported it. You can see that's the name of it. It'll give you the size here. And this is version 1.0.0. We highly recommend using semantic versioning. In the future, there'll be some built-in things that use semantic versioning as far as determining update paths and things like that. And so you can use any versioning scheme you want. However, we recommend semantic versioning. We'll just say this is version 1.0.0. We'll click Upload. And you'll see that it makes it the default because it's the only firmware that we've uploaded at this point, and there are no devices using it. Now, to change that, we need to, for the first time, somehow get this firmware onto our device so all future updates can be done via Deploy the Fleet. So we'll come back over here to the Arduino IDE. I'll keep the serial monitor open. Now that we've done that, we'll go ahead and click Upload, and now it's going to upload the Deploy the Fleet enabled version of the firmware to our device. And the ESP8266s take a little bit of time to do this. They're not the fastest flash chips. The ESP32s are much faster, but it'll upload this firmware, and then over here in our serial monitor, we'll see the exact same output that we saw before, which is it'll go through that setup loop, and then it'll say this is version 1.0.0. And so we'll go ahead and wait for that. We're almost finished. Okay, 100%, great. It's going to reset. You'll see setup 3, 2, 1. This is version 1.0.0. This time, however, what it's going to do is it's going to connect to an NTP server to get the current time. All of these transactions are done over HTTPS with Deploy the Fleet, and so we need an accurate current time so we can validate the TLS certificates. And so once it does that, it will report to Deploy the Fleet, I'm version 1.0.0, are there any updates? And the service at this point will say, no, you're on the current update. So now if we come back in here and we come over to the Devices tab, you'll see no devices have connected yet. We can just refresh that with this button here. And you'll see it's got the MAC address of our ESP8266 chip, the last checked in time, and the reported version as 1.0.0. Again, all of this is handled for you by the library using the Arduino Core OTA functionality. It integrates seamlessly with Deploy the Fleet. Okay, so now what we've done is we've taken this device and we've put it out into the field. That could be my garage, garden, a storage unit somewhere. It's no longer here, or it's in the hands of one of your customers. And so you can't have them open up the Arduino IDE, plug it in, upload firmware that way. And even if you had a way to do it over the wire, you'd need to give them a file, they'd have to upload it. It's all a big pain. And so what we're looking for is this seamless integration where, again, by the push of a button or a web UI, or in our case, just resetting the device, it will automatically look for updates and install them. And so let's make a change to our firmware that we need to deploy. So we're going to change the version number, first of all, to version 2.0.0. And I don't like how slow it's flashing. I want to speed that up. So I'm going to change the 500 to 100. So it's going to be a much faster flash. This is a crucial firmware update that we got to get out to people right away. And we'll go ahead and verify that to make sure we haven't made any mistakes. You notice I did not click upload. I just clicked verify so that it's compiling it. That built just fine. And now I'm going to do the same thing. I'm going to do sketch, export compiled binary. And again, this is going to export it into the folder where my sketches reside. And instead of at this point of uploading it to the device, because remember the device, let's pretend, is no longer attached to my computer, it's off somewhere in the field, but I need to get this firmware to devices. So I'm going to come back in and deploy the fleet and say upload a new firmware. I'm going to drag my latest version over. I'm going to change the version to 2.0.0. And notice this time I have an option to mark it as default. That wasn't an option for the first firmware because it automatically makes the first firmware the default. But on all subsequent uploads, I can choose whether I want this to be the default or not, which in this case I do. So I will select that and say, this is faster, Blinky 2.0.0. Okay, and I'm going to upload that. Now you'll see that it makes it an active firmware because it's marked as the default, even though there's no devices using it. And firmware 1.0.0 is still active because as far as this service knows, there's still one device out in the field using it. And so now that we've done that, all we have to do in our case is reset the device. I'm not going to use the Arduino IDE to upload to it, but I will keep the serial monitor open. And so I'll hit the reset button, and it's going to count down again, 4, 3, 2, 1. It's still going to say it's version 1.0.0, but now it's going to, again, check deploy the fleet for an update and say, do I have an updated firmware that I need to flash to myself? Again, it connects to the NTP server, it goes through all that, and makes a decision on whether it needs to update or not. And what we can do in the meantime is, again, it takes just as long as the Arduino IDE, as you saw that percentage clicking up, it takes about that long to deploy to itself in the field. And while we're doing that, if we come back over to deploy the fleet and come to the devices tab and hit refresh, you'll see over here the reported version has changed a little bit. It says it's running 1.0.0, but update 2.0.0 has been sent to the device, but it's awaiting confirmation. So we've sent an update to the device and we need it to report back in. So right now you can see it reset. It's now saying 4321. Now you can see it says this is version 2.0.0, which is really cool. So the update has succeeded. It's going to, again, based on our logic, check in one more time with deploy the fleet to say, are there any updates? Deploy the fleet will say, no, you're on 2.0.0, which is the current update. And so the result will be our LED is now flashing much faster. And so that's great. Now that it's done that, if we come back to the Devices tab in Deploy the Fleet, and hit refresh again, you'll see now the reported version is just 2.0.0 because it's confirmed with the service that the update is running. So very cool. And again, you can come back to the Firmware tab. Just really quickly, we'll show you the active firmware now is just 2.0.0. There's one device running it, and it's moved 1.0.0 down to the inactive firmware because it's no longer being used. However, if you decide that you want to go back to the slow blink, people hate the new fast flashing LED and we want to slow it down, you can always come back to version 1.0.0, click on it, and click set as default, and then that will make it the new default firmware. You reset the device, it'll come back, deploy the fleet will take care of it, roll that device back, and you'll be back to running version 1.0.0. So that's a very quick way, again, single line of code to get your ESP8266 Arduino Core project connected to deploy the fleet. If you have any questions, please feel free to reach out, comment. You can always find us at support@deploythefleet.io. Happy to help with any questions or issues you may be having with the service.